The graph of f of x is equal to minus x squared plus 4 and g of x equal to x plus 2, which is the linear function, are sketched below. B and C are the x-intercepts of f of x. So that's the parabolic function. A and D are the y-intercepts of f of x and g of x respectively. So A is the y-intercept of f of x and D is the y-intercept of g of x. F of x and g of x intersect at B and E. So there's the point of intersection. So just reading the question, we know at this point here, the value of Q represents two things. It represents the turning point and the y-intercept, right? The value, this minus the fact that A is less than 0. So we know that the concavity of the function is concave down, right? From the linear function, I can deduce the y-intercept, right? So from the value of Q, or C rather, I can deduce the y-intercept, which is the coordinate of D. The points of intersection, I can equate the functions at these points, B and E, I can equate the functions and solve. Okay? So, let's solve the question. Write down the coordinates of A. We already concluded that the coordinates of A is actually the turning point, or we could say that it's the y-intercept of the function. And so the coordinates of A is where x is 0, since it's the y-intercept, is 0 and 4. 5.1.2. Write down the coordinates of D. The coordinates of D, that's the y-intercept of the g of x function. So D will be 0 and 2. Like we're just reading from the equations. 5.1.3. AO, remember AO will be the y value at the top. So remember this as coordinates 0 and 4, and the origin as coordinates 0 and 0. So y at the top minus y at the bottom, 4 minus 0. So that will be 4 units. 5.1.4. Calculate the coordinates of B. So the coordinates of B, we can calculate in one of two ways. It's either we can equate both the functions and solve, or we can just find the x-intercepts of the f of x function, which is a parabolic function, and you take the x-coordinate that's negative. Remember, because it's lying on the negative x-axis. So if we solve for this, let's just structure this out properly. The x-intercept, y is equal to 0. So at the x-intercept, y is equal to 0. So minus x squared plus 4 is equal to 0. X squared is equal to 4. Remember that whenever we are using the square root, you must include the plus or minus sign. I read this, I think it's under the section of surds. I explained this in detail. So plus minus 4 is equal to plus or minus 2. So remember that since we're solving for B, x has to be less than 0. So it's minus 2. Then I input this value of minus 2 into either of the functions. So I'll just say f of minus 2 is equal to minus. Remember, whenever we make a substitution, we must parenthesize squared plus 4 is equal to, so minus 2 squared is 4. That's minus 4 plus 4, which is 0. Oh yeah, so in fact we didn't need to solve for that because it was the x-intercept where y is 0. We stated it there. So therefore B has the coordinates minus 2 and 0. So this step was not necessary. Okay, determine the coordinates of E, a point of intersection of f of x and g of x. Okay, so point of intersection of f of x and g of x. So basically in this equation, whenever we're dealing with a point of intersection, we know it's a point at which the x value and the y values of both the graphs are equal. So what I can say, 0.5, is that y is equal to minus x squared plus 4 and y is equal to x plus 2. I can equate these both functions. So minus x squared plus 4 must equal to x plus 2 because we're given that it's the point of intersection, right? If I take the x across, I'm going to write this in descending powers. Right? I'll write this in descending powers. So we have some structure. So that's plus 4 minus 2 becomes plus 2 is equal to 0. Let's multiply by a negative to avoid working with the minus sign. So that becomes plus x. That becomes minus 2 is equal to 0. two numbers that when multiplied together gives me -2, but when added gives me 1. That would be, what's the two numbers? Remember, 2 is a prime number, so that would be 2, and that would be 1. 2, x minus 1, right? Remember, so x is equal to -2 or x is equal to 1. Remember that -2 is not applicable. Why is it not applicable? Because x has to be greater than 0. Remember, we're solving for the e coordinate. And so if I want to find the y value, now I can input it into either of these functions. So I will do that for the linear function. So g of 1 is equal to 1 plus 2, which equals to 3. So therefore, the coordinates of e is 1 and 3. Okay, that's solved. For which values of x will f of x be less than g of x? Okay, now this is a interpretation type question. Now, whenever we're dealing with the interpretation type question, I want to talk about two things: intercepts and the intersections, right? Intersections. Right. Intercepts, remember we got our x-intercept and we have our y-intercept. And intercepts is where both the graphs are equal. So in our case is where f of x is equal to g of x. So the y and the x values are equal. Now to us, it's not simply, x-intercept is not simply where the y value is 0. Well, it is, but we can infer more from the intercepts than just this. And the x-intercepts is not just where x equals 0. We can infer more. So basically, in secondary school, right? In secondary school, so from grade 10 to grade 12, this is something that you need to remember. That at the intercept, at the x-intercept, let's say, at the x-intercept, the nature of the y value changes. And at the y-intercept, the nature of the x value changes. So what does this mean? Let's say I have a linear function, and this is the intercept. At that point there, if I move to the right, something happens. What happens? The y value, the nature of the y value changes. It becomes negative. And if I move to the right from this point, the nature of the y value changes because it becomes positive. So at that point, it's 0. But if I move to the left, it's negative. And if I move to the right, it's positive. The same thing applies for y-intercept. At the y-intercept, x is 0. If I move to the left, x becomes negative. If I move to the right, x becomes positive. When we start working with inequalities, and I'm sure you would have read about inequalities, you would see that I explain this in detail how at the intercepts, that's when the nature of the y value changes. Right? You'll see as we proceed with more interpretation type questions, you would see how this would play. Now here, intersections f of x and g of x. How does this? What else? It's not just simply where the x coordinates are the same and the y coordinates are the same. There's more to it. Like, let's see in our case here, right? Right. At these points, B and E, the functions have the same x value and the same y value. However, when I move to the left, what happens to the y values? The y value of one function is different to that of the other. Can you see that? If I move to the left, because if it was the same, then these functions would have overlapped. They would have intersected. The fact that they're not intersecting, the fact that they're not overlapping means that one value is greater than the other. In this case, can you see when I move to the left, the y value of the g of x function is greater than the y value of the f of x function. So the y value of the straight line is greater than that of the parabolic function. Now simply, if we move to the right, we see that the y value of the parabolic function is greater than that of the linear function. Right? And you can see that this applies until we come to b. So that's how we're going to think. So we're going to say it's your negative infinity. Then we move on to b. Then we move on to e. We move on to e. So these are like my significant points. Right? Remember, you will see this a lot. Intercepts and intersections. E. And then we move on to positive infinity. Right? Okay, anyways. For values greater than e, we see that the y values of the linear function is greater than that of the parabolic function. Now, simply what this question is asking us, remember they're asking us what values The fact that they're asking us means that there's a range of values. There's a set of values that satisfy the statement. Okay, there's a set of values that satisfy the statement. So they're asking us, give me a set of x values such that, or give me a set of x values that when I input it into the f of x function, so when I input that, so let's say, give me some random or a set of x values, that when I input it into the f of x function, and I input that same value into the g of x function, so the line graph, I output a y value of the g of x graph that is greater than the f of x graph. Do you see that? So in our case, you can see I actually gave you part of the answer. If I put an x value that lies to the left, remember I did not say where they are equal. If I want to say where these points equal, I would have included the equal sign here, but they did not. So they said, give me a value such that when I give me a set of x values such that when I input it into the function, I yield a y value of the g of x graph that is greater than the f of x graph. And you see that when I put any value that lies to the left of b, you see what happens. The functions g of x, the y value of the g of x function is greater than that of the f of x function. So we see to the left of b, we can say that g of x is greater than f of x. Now let's see, if I go to the left, remember I'm not going to include the value of b again because we do not want to include where they are equal, where the functions are equal. Otherwise I would have had a bar here at the bottom, equal to sign there, right? But we do not. We know that between, can you see that between b and e, we see that if I input any value of x, the value of that these functions output will be such that the f of x function is greater than that of the g of x function. But we do not want that. We want values of x for which the g of x function is greater than the f of x function. So we know that between here, b and e, we have points where f of x is greater than g of x. Now this is not a solution. We already know that it's not a solution. However, if we move towards the left, if we go towards the left of e, towards the right of e, we see that we begin to output values where g is greater. So the y values of the g of x graph is greater than the y values of the f of x graph, right? We see that because you can see the graph is lying above. We see the graph is lying above. And so therefore, this is also a solution. This is also a solution where g of x is greater than f of x. And so therefore, in order for us to solve this, this is why they asked us to solve for coordinates b and e. So what is the coordinates of b? Okay, I remember it was -2 and 0. I think this was 1 and 3. This value was 1, yeah, 1 and 3. So therefore, for values less than -2 and for values greater than 1. Rather, you can't say and because the function can't be used for. For values where x is greater than 1. And that's how you solve this problem. Okay. Okay, let's move on to the next question. In this question, okay, so the function t of x is equal to k to the power of x plus q is described by the following properties. K has to be greater than 0. That's a standard property of exponential functions. K is greater than 0. In order for it, right, it's a standard property of an exponential function, right? In order for us to define this as a function, the base has to be positive. K cannot be equal to 0, right? That's standard as well. The x-intercept at 3 lies at 3 and 0, okay? And we have here that the horizontal asymptote is at y, is equal to -8, okay? So what we know is that this function, okay, let's draw the asymptote first, right? The asymptote is very important. Let's draw the asymptote first. It either lies from the information that we were given. It either lies above or below this asymptote. That's what we know already. However, from the standard form of the exponential function, this is the standard form. The value of a, so the number or the value of the number rather, that lies in front of the base will tell you whether the graph lies above or below. And you see in front of k, it's positive. They could have made it negative, but it's positive. So the fact that it's positive tells us that the function lies above the asymptote. So we know that the function lies above the asymptote. Now, this is very important to know. That the fact that the function lies above the asymptote, it could do one of two things above the asymptote. It could either be an increasing function above the asymptote or a decreasing function above the asymptote. We don't know, right? How do we find out whether the function is increasing or decreasing above the... how do we find out if a function, exponential function is increasing or decreasing? We find it out from the values of a and b. Since we know a is greater than 0, but we do not solve for b yet, so we cannot really conclude much. So let's solve the question, and as we progress, we'll conclude. Okay, so 5.2.1, write the range of the t of x function. And we already discovered that the function lies above the asymptote of -8, so therefore it'll be y is greater than -8. Y element of real. Right? 5.2.2. Right, now they tell us to determine the equation. Remember, -8 is q, the value of q is the asymptote. So t of x is equal to k of x minus 8. I can substitute the point. 0 is equal to k cubed minus 8, and so k is equal to, the minus goes across, so k is equal to 2, because we find the cube root of, k cubed is equal to 8, so therefore k is equal to 2. Now we can conclude that since k, which is actually the b from the standard form, so since k is greater than 1, so it's not a fraction, it's not something that lies between 0 and 1, it's greater than 1. And since a is greater than 0, therefore we have an increasing function that lies above the asymptote, right? Okay, and so we can sketch this function quite easily now, because we know that the function lies above, right? So what we can do is we can draw the graph. We know that the x-intercept is at 3 and 0. So at this point here, that'll be 3 and 0. So, right? Okay, and remember, y-intercept, remember for the parent function. Remember, the parent function is a function that has no transformations and no translations. So, the parent function was drawn or assumes a shape as such, and has an x-intercept of, a y-intercept of 0 and 1. Now, what happens? What does the asymptote do? The asymptote shifts the entire function. So what did this asymptote do? It shifted the entire function 8 units down. So every point that the parent function outputs, right? So we got y is equal to, let's say, 2 of x. Every output of this function, we're taking out 8. Can you see? So this function was on its own. Now we're just deducting 8 from every value that it outputs. So every value that this outputs, I deduct 8. So at this point here of the parent function, it was 0 and 1. So what I'm going to do, I'm just going to say 1 minus 8, because I'm going to shift it down by 8 units. And it gives us minus 7. So our function should look this, right? Should look like this. So we got y is equal to minus 8. Right? The function should go from here, go up. Call this point 3. Right? And at this point here, it should have a y-intercept of minus 7. Right? You can include your arrows because this goes to infinity. Yeah. And so that's the part, and then you have to label the graph. So this is the graph of y is equal to 2 to the x minus 8. And so this is the solution of this question. Okay, yes. So how do we know? Okay, yes. Using the values of a and b, how do we know whether a function is increasing or decreasing? So yeah, let's explain that. So remember, we have the standard form y is equal to ab to the x plus q. Remember that b has to be greater than 0 and b cannot equal to 1. We have two possibilities. A can be greater than 0 or a can be less than 0. If a is greater than 0, the function lies above the asymptote. If a is less than 0, the function lies below the asymptote. Now with b, we have a few options. B can be greater than 1, right? Or b can be between 0 and between 1. Okay? Okay. Yes, and so with this, we have one of 4 possibilities. Right, so b can be greater than 0, less than 1. It's either a can be greater than 0 and b can be greater than 1. Or a can be less than 0 and b can be greater than 1. Or a can be greater than 0 and b lie between 0 and 1. Or a can be less than 0 and b lie between 0 and 1. Now, with this information, how do we know whether a function is increasing or decreasing? Firstly, let's try to create an idea of what an increasing or decreasing function will look like above and below an asymptote. If we're trying to draw an increasing function above an asymptote, it should look something like this. It should assume this shape. If we want to draw a decreasing function above an asymptote, it should assume this shape. If you're going to draw a decreasing function below the asymptote, it should assume this shape. And if you're going to draw an increasing function below the asymptote, it should assume this shape. And so knowing this, you kind of see like it's just a quick diagram that we can refer to when we're trying to understand whether a function is increasing or decreasing. But remember the exponential function, to be more specific. Remember that an increasing function is a function that as x increases, y increases. So an increasing function is a function that as x increases, y increases. So we're reading the function from left to right. So from left to right, what happens? The y values are getting bigger. A decreasing function is a function that as x increases, y decreases. So you see here, as x is increasing, reading from left to right, the values of y is decreasing. Getting right, it's decreasing. Now, how do we define? Remember, in our case, the way we will do it is that when we see the arrowheads pointing in the same direction, this is just a quick way of remembering. When the arrowheads are pointing in the same direction, the function is increasing. When the arrowheads are pointing in the opposite direction, the function is decreasing. Whether it lies above or below the asymptote, that's determined by a, whether a is positive or a is negative. So in this case, this function is increasing above the asymptote. How do we draw that? We draw it as this here. See, above the asymptotes, I look at these two possibilities. Which function is increasing? It's this one, because the arrowheads are pointing in the same direction. And so this function should look something like that. In this case, this function, and we're trying to look at the function below the asymptote, so that will be these two possibilities. Is it increasing or decreasing? It should be a decreasing function, and it should assume this shape. Okay. Again, we can do the same thing here. This function is decreasing above the asymptote, and this function should be a function that increases below the asymptote. So it should assume that shape. It's increasing.